Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 2 for this week. And it turns out that way back in 1946, there was a gentleman named J.E. Miller that developed a low pressure area or cyclone classification system. And it was used primarily to forecast the intensity of nor'easters, the storms that move up the East Coast and dump all sorts of snow, and specifically for the mid-Atlantic and also the northeastern coast of the United States. So the technique has been in existence for a long time. What, 54 plus 25 is 79 years, but it's still used today. So obviously this guy was way ahead of his time in terms of coming up with really useful forecasting techniques. So there's Miller A and Miller B, and the storm we're going to be dealing with Friday night is a Miller A, and I am going to put myself down here in the corner so you can see this. All right, so we've got the United States there, or parts of it. So if a storm actually develops either along the Gulf Coast or in the Gulf of Mexico and then moves northeastward along the coast, then that is a Miller A storm. It is the primary storm from start to finish. There's no secondary storm. This thing is, this is the main guy, the main player. And so when it goes up the coast, it dumps all sorts of precipitation along with it. Now, there was a study done at the National Weather Service office in Raleigh years ago, and it actually looked at documented cases, and it showed that with Miller A storms, the transition zone from frozen to liquid is usually very narrow, okay? That there's not like a huge area of icing that develops in storms like this. And so that's why I'm a little bit skeptical about this being a serious freezing rain threat on Friday night. Number one, there may not be enough precipitation for it to be a major event. But the other thing is that typically with these kinds of storms, you don't get a huge icing area. So what you would look for then, you'd have rain basically ahead of the cold front and then north of the front to the north and east of the low. And then there would be a very narrow transition zone, okay, which I've shaded there in a sort of a light transparent red. And then there'd be a snow area on the other side of that. But again, the main key here is the transition zone is usually quite narrow. Now, if we take a look at a Miller B scenario, we've got Arctic high pressure up to the north, okay, probably even a little farther north than that, but that's as far north as I could put it on this particular map. And then what you see is a storm actually over land, okay? It may have developed out in lee of the Rockies somewhere, and it's headed up toward the north and east, and you get one of these loop-de-loop fronts here because of cold air damming, that this high is keeping this shallow layer of cold air in existence all the way down into Georgia, okay? And so the warm air surges northward into southern West Virginia, and there can be a lot of times where it's warmer in West Virginia or even Pittsburgh than it is in the Piedmont of North Carolina in these kind of scenarios. Well, as the low approaches the mountains, a lot of times it will start to weaken, and the upper level support, the wave in the upper atmosphere that is associated with this, begins to move over this area in here where we've got a front, okay? And that's an area of convergence. And so when you basically cause rising motion over an area of convergence, then that vorticity just intensifies, and eventually what happens is a new low develops. So in this kind of a situation, you would have a wider transition zone, okay? And the snow in association with the first low would be moving off toward the north and east, but then as this new low developed along the coast, then it would begin to intensify its own area of snow or create its own area of snow and then move up the coast and dump on the middle Atlantic and the northeast. One of the interesting things about North Carolina and South Carolina and Georgia, we are the only 3 states in the entire U.S. that have a warm body of water adjacent or close to a mountain range, okay? And so in the wintertime, when these cold air masses come in, and we're certainly in the midst of that now, a natural frontal boundary sets up along our coast because the Gulf Stream is warming the air above it, and the cold air over land is creating a lot of contrast with that warm air just off the coast. So you have a natural front that's almost always going to be there every time a cold air mass comes in. And then if something's going on in the upper atmosphere that can come along and interact with that frontal zone, then all of a sudden you can get pretty rapid storm development. But again, it does not look like this is what we're dealing with on Friday. There's one low only, and it originated along the Gulf Coast, and now it's going to move up along the southeast coast. So no secondary low, not a lot of cold air damming. The thing about this particular situation is that there is no big high to the north, and so we're simply going to have to make use of the cold air that is in place, and that'll be enough at the beginning of the event, but I think toward the end of the event it's going to be really difficult to keep it all snow, because it's going to be warming up both at the surface but especially aloft, and once that happens, then all bets are off on snow. All right, that is it for now. That's bonus weather video number 2 for this week. Number 3 will be coming up on Friday, and the next daily weather update, of course, coming up tomorrow. So we're getting closer and closer to Friday night, and hopefully we'll be able to pin down some details as we get closer and closer to verification time. All right, that's it for now. It's very late. You probably won't see this until Thursday, but when you do, I hope you're having a wonderful day. So we'll talk to you soon. See you later.